All right, this is number 4. So we've got Sam, we've got his mass. He jumps off of a raft that's floating in a lake. He jumps off with a velocity of 3 meters per second. What is his final velocity, or what is the final velocity of the raft? Okay, so this one is a separation or an explosion. Okay, so initially we've got Sam, and he's on this raft in the lake. He's having a nice day at the lake with, I don't know, family, friends, whatever, who knows. So he's going to jump off this raft, and imagine the raft is going to move in one direction, and Sam, he's going to be flying off in the other direction in the air. Okay, after he jumps off the raft. So imagine he's out in the lake and he decides to jump off and swim. So initially, he and the raft are at rest. They're floating in the lake. So I mean, they're moving through the lake. But from the purposes of the problem, we can approximate that they're at rest. Okay. So here we're going to have a combined M1 plus M2 VI initially, and then we've got M1 V1F plus M2 V2F because then Sam and the raft are separated from each other. So if our initial velocity, our initial velocity is of them both is 0 because they're just hanging out in the lake. M1 is 55. Hang on a second. Okay. Such pain. M2 is 5. That's the mass of our raft. And then Sam's final velocity, V1F, is 3 meters per second. And we want V2F. Okay. So we're starting off with 0. Okay. M1 plus M2 times VI is 0. So we know our total momentum's conserved. So that means that we are going to expect Sam and the raft to have an offsetting momentum from each other. And we see that they're moving in opposite directions. So one of these is going to have to be positive and one is going to have to be negative in terms of direction. Okay. So we'll see how this all works out. So we've got Sam's mass of 55 times his final velocity of 3. So that's what I'm filling in here. Plus 5 for the mass of the raft times V2F. We don't have that. Let's see. Let's multiply 55 times 3. That's 165. So I'm going to take this 165 and subtract it from both sides. That's going to give me minus 165 on this side equals 5 times V2F. So we can see that we've got our negative direction here. Our raft is going to be moving in a negative direction because they're going in opposite directions after the separation from each other. And that happens a lot with separation. 165 divided by 5 is 33. And so my V2F is minus 33 meters per second. So that's how fast the raft is moving after Sam jumps off it. That's pretty fast. So Sam gave it a good push as he jumped off, and his velocity also changed. Is kinetic energy conserved here? No. Nope. Not for separation. Because again, you've got this separation occurring, which is going to change the energy makeup, I guess, of our scenario. So our initial KE is going to be 0 because we said they're at rest in the lake. So both of them, they have an initial velocity of 0. Final kinetic energy. So we're going to have 1/2 Sam's mass and his final velocity squared plus 1/2 times the mass of the raft times minus 33. Now the minus is going to go away here when we square it. Squared. So let's see. 0.5 times 55 times 3 squared is 247.5 plus 0.5 times 5 times 33 squared, and I'm not worrying about the negative, 2722.5, because the negative is, it's going to get squared, so it's just going to go away. So that gives me a final kinetic energy of 247.5 plus 2722.5, 2970 joules. So we picked up 2970 joules of kinetic energy. That means we had to have some kind of corresponding loss of energy, transformation of energy out of our system for energy to be conserved. So we had 2970 joules of Ke. So 2970 joules was lost due to energy. And so energy was lost from Sam and the raft. It went off somewhere else into thermal, maybe with the friction between Sam and the raft as he jumped off of it, or the friction between the raft and the water. I don't really know exactly for sure, and we don't have to calculate that necessarily. Those particular energy transformations, we just need to know that we should end up with a total energy of 0, because that was our, or at least kinetic, that was our initial kinetic energy. Okay, so so we got to have something offsetting this kinetic energy that was gained. So okay, so that is a separation example.